So today in exercise 1.3, okay, we are taking question number second, and second question is let f, g, h, these are three functions, be functions from R to R. These three functions from the set of real number to set of real number. Show that f plus g o h, f plus g o h equals to f o h plus g o h. f g o h is equals to f o h dot g o h. Okay, we have to show this. And these three functions are defined from set of real number to set of real number. Okay, so let us have the first relation, first equation, that is f plus g o h. Okay, and this is defined for x. For all x belongs to the set of real number. Set of real number, that is domain. Okay, so this is equals to f plus g o h of x. Okay, now this is equals to f plus g of h x. This is equals to, now this is element for f plus g. F plus g is the function and hx is the element, but here x is the element for the function h. Now when element x operate under f, this is element hx. Now this is element for f plus g. Okay, so f plus g o h x. Now f plus g o h x equal to f plus g h x, and this is equals to f of h x and plus g of h x. So this can, in reverse process, we write down as f o h of x plus g of h of x, and again in reverse process this can be write down as f o h plus g o h of x. Okay, after eliminating this element x, we will have f plus g of h is equals to f of h plus g of h. Okay, so this is the first part of the question number second. Now the second part is f multiply g of h, and we are taking the element x for all x belongs to R. Okay, so this is, now x is the element for function f. So f multiply g of h x. Now this hx is the element for this function. So f g h x. Okay, and this can be write down as f of h x multiply g of h x, and after reversing the process, we will have f o h of x multiply g of h of x, and again in reverse process f o h multiply g o h of x. Okay, after eliminating the element, we have f dot g of h is equals to f of h multiply g of h. Okay, so this is the second part of the question number second. Okay, now let us have the question number second part of the question number third of the exercise 1.3. Okay, and this is find gof and fog. If function x equal to 8x cube and gx is equals to x to the power 1 by 3. Okay, so finding gof. So gof of x equal to g of function x, and this is equals to g of function x equal to 8x cube. Now this is not a function, this is an element. This is an element for the given function g. ठीक है, okay. So finding the image of 8x cube, finding the image of 8x cube under the function g, okay. And gx is equals to x to the power 1 by 3. So this is equals to 8x cube to the power 1 by 3. And 8x cube can be write down as 2x to the power 3 to the power 1 by 3. 3 will cancel 3 and this is equals to 2x. So golf of x equals to 2x. And log of x, also we are going to find log of x. Log of x equals to function of gx. Function of gx. That is function of gx, that is x to the power 1 by 3. Okay. Now x to the power 1 by 3 is not a function. This is an element for f. And image of x under f is 8x cube. So image of x cube under f is 8x cube, that is x to the power 1 by 3 to the power 3. Okay, 8x cube, x is equals to x to the power 1 by 3. So this is equals to 8 into x. Okay, so log of x equal to 8x and log of x equal to 2x. In this way we can find log and log. We are here on the topic composite functions, okay. And to understand what does mean by composite functions, you have to go to the previous video. Here in that video I am doing the exercise 1.3, but in that video, in previous video, I have the different topics, okay. So this is question number 4, okay. And I am reading the question. If function x equal to this, x is not equal to 2 by 3. Because at x equals to 2 by 3, the given function is not defined. Show that f of x equals to x. F of x, function of function x equals to x. What is the inverse of x? Firstly, this is first part, f of x equals to x, then inverse of f. So there are two parts in this question, okay. So firstly we have to find f of x. F of x equals to function of function x. Function of function x, that is function of function x. Function of function x can be write down as, this is an element and this is function, and image of x under f is this. So image of fx under f is 4 into function x plus 3 upon 6 into function x minus 4, okay. Now put the value of function x. Again put the value of function x, that is this. So this is equals to 4 into function x, 4x plus 3 upon 6x minus 4 plus 3, okay, upon 6 into function x. Function x is equals to 4x plus 3 upon 6x minus 4 plus 4. 6x minus 4 upon minus 4, okay. Firstly, we have find the image of function x under f, and image of x under f is this. So image of fx under f is 4 function x plus 3 upon 6 function minus 4, okay. Now we have put the value of function x. Put the value of function x, that is 4x plus 3 upon 6x minus 4 in place of fx. Now we are going to solve this. So taking LCM 6x minus 4 at numerator. This is 4 into 4x plus 3 plus 3 into 6x minus 4. And in denominator, again taking the LCM 6x minus 4, and this is equals to, after solving, 6 into 4x plus 3 minus 4 into 6x minus 4. Okay. Now solving this, we will have function of function x is equals to 4 4 is 16x plus 4 3 is 12 plus 3 6 is 18x minus 12 upon LCM will cancel LCM. So 6 4 is 24x plus 6 3 is 18 minus 24x plus 16. So this is equals to 12 will cancel 12, 16 plus 30, 16 plus 18 34x upon 24x cancel 24, 18 plus 16, 34. So f of x equals to x. Okay, so this is the first part of our question number 4. Okay, now the second part is what is the inverse of f. Okay, whenever we were studying invertibility, we have told you that any function g is inverse of f if f of x is equals to identity. Okay, so f here in this question f of x equals to x, that is identity of x. So f equals to identity. It means f is the inverse of f. F is the inverse of f, implies that inverse of f equals to f. Inverse of f equals to f. Okay, so this was question number. Okay, so this is the question number 6. Show that the f from -1 to 1 to r, okay, is given by function x equal to x upon x square plus 2. X upon x square plus 2. Function x is equals to x upon x plus 2. X plus 2 is 1, and also we have to find the inverse of the given function up to its range. Okay, so f is, we have to show that the given function is 1, 1. So 1, 1. Okay, now function x is given as x upon x1 x plus 2. Let x1 x2 belongs to the domain of the function -1, 1, such that function x1 is equals to function x2. Function x1, that is x1 upon x1 plus 2 is equals to x2 upon x2 plus 2. Okay, now after cross multiplying, x1 into x2 plus 2 is equals to x2 into x1 plus 2. So this is x1 x2 plus 2x1 is equals to x2 x1 plus 2x2. So this one cancel each other. 2x1 equals to 2x2 means x1 is equals to x2. Okay, so we have taken function x1 equals to function x2 and prove that the x1 equals to x2 implies that f is 1, 1. Okay, we are not to check whether the given function is onto or not, because it is not given in the question. Okay, so we have just to check only the given function is 1, 1. So we have checked that the given function is 1, 1. Now the second part is find the inverse of f from -1, 1. Domain is -1, 1 and range is f up to f. Okay, so second part of the question, that is inverse of f. Okay, we have find the inverse only, not to prove that the given function is invertible or not. Okay, so directly we have to find the inverse. So function x is given as x upon x plus 2. Okay, this is the function inverse. We are going to find the inverse of the given function. So function x equal to x upon x plus 2. Let us say this is equals to y. This is equals to y. So x is equals to y into x plus 2, and x is equals to xy plus 2y. So x1 minus y is equals to 2y. So x is equals to 2y upon 1 minus y. Okay, so 2y upon 1 minus y. 2y upon 1 minus y is x, and x is the inverse of the f. Okay, so inverse inverse of f is equals to function inverse x, that is equals to 2y upon 1 minus y, that is 2x upon 1 minus x. Okay, so this is the inverse of the given function. So this is question number 9. I am reading the question. Consider function f r plus set of positive real number 2 minus 5 infinity. This is range or this is codomain. Given by function x equals to, this is the function given by function x, 9x square plus 6x minus 5, and we have to show that this is invertible. Given function is invertible, and also we have to find the inverse. Okay, so the aim of our question is to show that the given function is invertible. Okay, now let us have a trick, that when the given function is in quadratic form, when the given function is an quadratic expression, we will show that GOF equal to 4 to show that given function is invertible. Okay, and if we want to show that given function is invertible, we have to show that GOF equals to 4. GOF equals to 4 means we will take the help of composite function. Okay, the definition of invertibility says that a function f is invertible if there is another function g such that fog equals to GOF equals to identity function. Okay, so we will show here that fog equals to GOF equals to identity function. Okay, so first of all we will find the g. Okay, the given function is, solution is just like this. Function x is equals to 9x square plus 6x minus 5, and let us take this is equals to y. Now we will find x in terms of y, and that x will be gx. Okay, so now we will find x in terms of y. So 9x square plus 6x minus 5 plus y equals to 0. This is x, coefficient of x square, coefficient of x, and 5 plus y is constant. So using x is equals to, using quadratic formula, x is equals to minus b minus 6 plus minus under root b square, that is 6 square minus 4 into a into c, that is minus 5 plus y. So this is plus upon b square minus 4ac upon 2a and 2 into 9. So this is equals to minus 6 plus minus under root 36 plus 4 9 is 36 into 5 180 plus 4 9 is 36 y. Okay, divided by 2 9 is 80. So minus 6 plus minus 6 plus minus, taking 36 216 plus 36 y upon 80. So x is equals to minus 6 plus minus, taking 36 outside the square root 6 under root 216. Okay, 36 6 plus y upon 80, and after solving this we will have minus 1 plus minus under root 6 plus y upon 3. Okay, but function is from R plus means domain is set of positive real numbers. That is why it should be positive. So remove the negative sign. So x is equals to minus 1 plus under root 6 plus y upon 3. And this x is g. So let gx is equals to minus 1 plus under root 6 plus x upon 3. So this is gx. Okay, so we have find gx. Now we will show that GOF of x equals to x and fog of x equals to x. That is fog equal to gof equals to identity. So first of all, finding the gof of x. Finding the gof of x. Finding the gof of x. Gof of x is equals to g of function x. Okay, so g of function x. Image of x under g is this. So image of fx under g is -1 plus under root 6 plus function x upon 3. So this is equals to 1/3 minus 1 plus minus 1 plus under root 6 plus function x. Function x is 9x squared plus 6x minus 5 upon 3. So 1 upon 3 minus 1 plus under root 9x squared plus 6x plus 1 and this is equals to 1/3 minus 1 plus under root. This is 3x plus 1 whole square. Okay, this is his quadratic equation after squaring will become 3x plus 1 square. So this is equals to 1/3 minus 1 plus 3x plus 1. 1 will cancel 1, so 1/3 into 3x equals to x. Okay, so gof of x equals to x. Now fog of x. Now fog of x, that is function of gx. Okay, and image of x under f is this. So image of g under f is equals to 9 into gx square plus 6 into gx minus 5. So this is equal to 9 into gx. Gx is under root gx is minus 1 plus under root x plus 6 upon 3 square plus 6 into minus 1 plus under root x plus 6 upon 3 minus 5. Okay, now solving this we will have 9 into 1 upon 9 square of 1 upon 3 1 upon 9. Now squaring of minus 1 plus this means a minus b whole square. A square 1 plus b square is x plus 6 plus 2ab minus 2 into under root x plus 6 plus 3 2 are 6. 2 into minus 1 plus under root x plus 6 minus 5. So this is equal to 9 will cancel 9. 1 plus x plus 6 minus 2 under root x plus 6 minus 2 plus 2 under root x plus 6 minus 5 after expanding this. This will cancel this. Minus 5 minus 2 minus 7. So this is finally equals to x. Okay. So fog of x is also equals to x. Okay. Now we had so that gof of x equal to fog of x. Okay. Now gof of x is equals to fog of x equals to x. That is gof equals to fog equals to identity. Okay. Now what this identity says? This identity says that inverse of f is equals to g. Means inverse of fx equals to gx and gx is equals to under root x plus 6 minus 1 upon 3. Okay. So this is the answer of the given function or solution of the given question. So question number 13 of the exercise 1.3. Function is defined from set of real number to set of real number given by function x equal to 3 minus x cube to the power 1/3, then half of x is equals to, what is the value of half of x? Okay, so finding the half of x. Half of x, that is function of function x. Finding function of function x. So this is equals to function of function x. Function of function x. The image of x under f is 3 minus x cube whole cube root. Okay, so image of function x under f is equals to 3 minus function x cube and cube root. Whole power is cube root. So this is 3 minus function x. Function x is this 3 minus x cube. 3 minus x cube to the power 1 by 3 whole power 3 and whole power 1 by 3. Okay, putting the value of function x. Putting the value of function x, that is 3 minus x cube to the power 1 by 3. Okay, so 3 will cancel 3 and this is equals to 3 minus 3 plus x cube to the power 1 by 3. Then 3 will cancel 3 and this is equals to x cube to the power 1 by 3, that is equals to x. So half of x is equals to x. Half of x equals to x, that is what this relation says. This says that the inverse of function f is the function f itself. Okay, that is f inverse of f inverse is equals to the f itself. Okay, so this was question number 13 of the exercise 1.3.